So in the previous class, we are doing about the modeling of linear regression, and I suppose I had explained the all the steps. Now today we will discuss about how how we can able to create the model, and then I have to fit that particular model into the linear regression. After that, we will calculate the accuracy and so on. So, uh, moving forward, so we will see an article about the linear regression. Skeleton linear regression.
Sir, we cannot see the screen.
Okay. So this is an article of linear regression, a simple linear regression. Now, the simple linear regression model is basically a supervised learning algorithm, and I told you earlier. Uh, So these things, they are using the path to finding the file I have created in different way. They have created in different way before retrieving the data from the data model. So these are calculated data head df dot shape, that is for scaling, and for the scatter diagram they are using different code over here. The same code which I had taught to you, the same code for scatter diagram. Now this is the coefficient, and this is the theoretical part of the regression model. Mm, This is for reshaping. And for training and testing the model, we use train test and test set. And how much percentage we will use for test size, and for the stability of the model we use the random state. Now, so I'm importing the pandas. Now, for linear regression, which I had told you it is used for the continuous function, linear regression is used for, that is for the continuous function. In case of the data analysis, we used as a continuous data. Now, it is linear regression is a supervised machine learning algorithm, and for a data set is given to me. That data set will be maybe on Excel, and if I wanted to convert a comma separated values, that is for CSV file, we can convert that particular Excel into a CSV file. And I am using the pandas, that is panda is one of the library function of Python, and which nomenclature is PD, because with the help of the pandas we can able to read that particular CSV file which I am importing into the Python environment. So the I'm setting in Google Colab, I don't have to set this particular path, right? I will just click on the click on this drop down, and it will automatically take the path, and I have to mention the path and the name of the file, and the pandas will be read that particular file. If I write for the df dot head means the data frame, df means data frame dot head means the first 5 values will be read by the pandas. Now this here, the in the data set which is given over here, this data set has only the one predicted value and one target values. So the predicted value is hour and the target value is score, and the corresponding result will be shown over here. And again, I am shaping the data set. That is, I am just scaling the data set, and I analyze it. That is 25 datas, 25 rows and 2 columns. If I want to plot that particular data set, that is this particular data set, if I want to plot that particular data set, I have to use that as I'm using the matplotlib as a library function. And in case of that matplotlib, there are two kinds of the visual data visualization takes place. One is by using the two library functions. I had told you that one is the seaborn and other is the matplotlib. With the help of the matplotlib, we can use the function scatter. That is not the function, it is the property, the scatter. With the help of this scatter property, that means with the help of the scatter diagram, we can see the how the data are scattered in the data frame. So this is the scatter plot, how the data are arranged. So with respect to hours and scores, the data set is given with the help of the present data set which is given to me. On that respect, the we are getting the scatter diagram. So data are arranged in these ways. After that, I have to find out the correlation, or the correlation method calculates and displays the correlation between two variables. That is the two variable, that is the degree of association of the two variables. So that is df dot correlation. This is the correlation function. That is the how I want to, how the two variables, that is x and y, that is hours and scores, how they are correlated to each other, how they are associated with each other. That is, if the hour increases, if the score decreases, or if the score decrease, if the hour decreases, the score increases. So in this way, the two variables, which are hours and scores, they are um, related to each other. So one increases, another decreases, and now one decreases, another increases. And if they are related in this manner, the two variables, if they are related in this manner, then we called it as that they are positively correlated, right? So this is the correlation. df dot describe. The describe function, I had told you, it gives you the statistical analysis. So the statistical analysis of the given data set, that is the count, mean value of the data set. We can able to calculate the standard deviation of the data set. That is the describe function gives the what will be the mean value of the data set, what will be the standard value of standard deviation of the data set, what is the maximum value, what is the minimum value. These are all given by this describe function. So describe function, the pandas also ships the greater helper method for statistical summaries, and we can describe the data set to get the idea of the mean, maximum and minimum etc value for our columns. So that is the mean value, maximum value, and the standard deviation, how they are correlate, how these statistical measurement can be measured, that can be determined by this describe method, right? Now this 25% and 50%, 75%, it is basically the testing of the data set. With the respect of the testing of the data set, the mean the the evaluated the accuracy of the data set is 2.7, with 50% of the testing value, the accuracy of the 4.8 and 4.80, and it is 47, right? So these are basically the testing value. Now for reshaping the data set, uh, we have to scale the data set. Before we want to establish the model, we have to scale the data set, right? And for scaling the data set, we use the reshape method. Now in the reshape method, for scaling the data set, we use this reshape method. In the reshape method, we are using this one is for the row and this one is for the column. Now this is -1 and this is +1. This -1 signifies that the numpy will decide that how many row is possible. That is been decided this for this -1, and the +1 means the first column. So how many row will be possible? That is been, this is row. The first one is row. The second one is for column. For first column, how many possible rows uh, can be possible? That is been decided by this -1. On the contrary, if we say that this is +1 and this is -1, that defines that how many column will be possible, how many column is possible with respect to first row. So if this is +1, that means first row, and if this is -1, then it will decide that how many column is possible, right? This decides how many column is possible, and this will decide the first row. Here also, the -1 decide how many row is possible, and this is for the +1 is the first column, right? So for scaling the data set, we have to reshape the data set. Now there may be a redundancy of data may takes place, right? So that can be also eliminated. And for OLS or ordinary least square method, we will see the different thing later on. I will discuss what is OLS. So df.hours.values, this will give the, that is, we will get the on different hours. Now this is for the hour column. This is the hours column, and after reshaping the score an hour by the numpy, now if I want to get the corresponding values, so it will give the values of the hour, right, and the form of a one-dimensional array. Now if I want to reshape there, if we want to shape that, that is how many, if I want to scale that particular column, then I will see that dot the values dot shape, right? So if I say print x dot shape, that means there were 25 rows in the first column, right? And the corresponding values will be displayed. Now, I said that in order to evaluate the model, we have to use one training set and test set. And training set is always used for the building the model, and test set is used for evaluate the model. So for that, we divide the data set into two parts. One is the X and Y, that is X train and X test, and Y train and Y test. Now, Y test is basically, now X train and X test. X train is for use for the building the model, which I told you that randomly the data will be taken from the predicted values, and the X test and the randomly the accuracy of the model will be determined by the X test. Similarly, for y train, we will take the y train, the different randomly, we will take the values from the target variable, and again we will test the model. Now we test this x test, that is the y test, with the y test. Now y test is basically my actual value. So y test is basically my actual value, and x test is my predicted value. So we will see that whether my predicted value is nearer to the actual value. If the predicted value is nearer to the actual value, then it's my model is gives the 90% or more than 90% of the accuracy. But if I see that if my X test gives the result, which is after evaluating the model, if the X test gives the result, and if I compare with the target value, and if it is seen that it varies a lot, then it gives that the my mm, that the model that I had developed is not so accurate, right? So that has been tested by this sklearn model. So this x train and x test, so it is I am splitting the model using the test size of 20%. So I'm testing 20%, and my testing model is 20%. My random state is seed is over here. You can make it as +1. Random state is basically used for controlling the model. That is for the stabilizing the model. That is called random state. If they are using seed, you can make it as 1. After that, I am importing a linear regression, and I'm developing a linear regression model with the given data set. And then I'm fitting that particular data set into the linear regression model. After fitting the data set, I am calculating the accuracy of the model. Now,
వస్తున్నా. డాడీ గేట్ ఎప్పుడు సరి గేట్ వర్షం ఏం పడట్లేదు ఇప్పుడు తీసాడు వీడు.
అక్కడే ఉంచాలి లాకాల మోసలు కనుక్కున్నాను నీళ్ళు రెడీ డబ్బులు పెట్టి
అట్టిది
ఇప్పుడు వాళ్ళ ఇంటి దగ్గర ఉండి స్టార్ట్ చేసిన కనెక్షన్
ఇది ఐశ్లమ్మ
ఆడవిడ ముందర
అన్నయ్య పడుతున్నారు ప్లీజ్ అనుకున్నారంట మనకి బాగా తీసేటాను అందుకే ముందుగా పెట్టుకునేసరికి అప్పుడు బాగా కట్ చేస్తాను
అప్పుడు పవర్ కట్స్
సమ్మర్లో బాగా కట్ చేస్తాను ఆపేసావా బటన్లు కథ బటన్లో ఒకటి నొక్కుతుంది
చేసి పెట్టుకోవటం
టైం ఇప్పటికే 9 అయింది మళ్ళీ భోజనం ఈ మధ్య ఫాస్ట్ గా ఎక్సర్సైజ్ గాలతుల గోలి
import numpy as import pandas. Import matplotlib dot pyplot
Sir,
SQL. Yes.
sir, your screen is not visible, sir.
From google.colab. Import file. Upload equal to file dot upload. df equal to pd. Now someone say the next code, what should I write?
df dot head.
Df
Sir, no, sir. df equals to pd dot read csv. We have to read first csv file we have uploaded.
pd dot read
Yes, sir. Read underscore csv.
read underscore csv.
Yes, sir. And in the
Then
bracket, first bracket, we have write the file name that we have uploaded.
file name.
Okay, diabetes dot csv.
Right? Then what should I write?
Then sir df dot head.
Head.
Yes.
Now someone tell me step 1, step 2, step 3 and step 4. What these steps actually mean? Someone please tell me step 1, step 2, step 3 and step 4. What these steps actually mean?
So the first steps is importing the files, library files, NumPy, Pandas, and Matplotlib. And
Hmm.
the second file is uploading the
Now,
our data.
I'm just interrupting you. The thing is that the first step is not importing the files. The first step what files? You are talking about the files. What files? What NumPy is
I'm talking libraries, library Python libraries.
so I'm importing the NumPy and pandas from the Python and which is inbuilt from the Python, and I'm importing this NumPy and pandas because the NumPy is used for the mathematical calculations and the NumPy is used for the arrays and for the matrix. They are all used for these things are defined in NumPy, and the pandas are basically used to read the data frame. That is why I am using the pandas. And I am also using another library called Matplotlib for the data visualization, of the given data set. That is why I am using Matplotlib. Right now, step 2,
Second step is uploading file,
what file I am uploading?
uploading data frame or CSV files
Where,
or any
I am uploading the data frame in where I am uploading?
Google Colab.
In Google Colab. So I'm uploading the given data set which is in CSV file and in the Google Colab environment. And for that I am using the from google.colab. This is a Google Colab environment. I'm importing the files, and for import files means that I am importing the files, which is that is the file that is my data set, and I'm uploading that particular data set in this Google Colab environment. That is why I am writing files.upload. This upload function is uploading this particular diabetes data set into this Google Colab environment, and I want to visualize that particular data set uh, into this environment, into this Google Colab environment, right? That is why I am writing files.upload, and it is uploaded in the variable upload. Now, what this step represent? The third step. Anushwa Mitro, can you say? Anushwa Mitro, are you there?
Yes, sir.
Can you say?
No, sir, I can't because I just joined the yeah, like Sunday, so I didn't finish all of the classes.
Anybody? Anybody who had joined for the previous class?
So visualizing the dataset.
This is no, not. This is a visualizing the data set. Is that?
Sir, may I?
Yes.
Sir, it is based for reading the data sets. PD.read
So
CSV.
PD is a panda.
Yeah.
That is a library dot read. So panda has a property called read, right? What is reading? The CSV file. That is the CSV file which is imported in this Google environment. The pandas will go to read that first using this read property. Therefore, what is reading? The CSV file. That is why I'm writing read underscore CSV. So this is object dot property, and this is basically is reading that particular file, the name of the file, and this is the name of the file which is been enclosed with this CSV, that is the read property, right? So that CSV file I am enclosing, since I want to display that particular CSV file, therefore I am enclosing that particular CSV file within the double quote. And this whole thing is being stored in the data frame, that is which is defined by a variable called df. So now if I want to see the by default the first 5 values from the data frame, I have to use the head function. The head function basically can the head function basically by default displays the first 5 values of the data set. Now in the data set, it is seen that all the datas which are arranged over here are in a random function. They are arranged not in a sequential form. They are not in the sequential form. They are not in a particular sequence. They are arranged in a random way. So here the datas are arranged in a random way. And all these values, these pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, all these attributes are basically, these attributes are the predicting predictor the predicting values, right? And the outcome, which is a dichotomic in nature, the values which are in dichotomic in nature, this is basically the actual values. So this 1 and zeros are assigned randomly with respect to these values. That means these are basically the hypothetical values, not for which are assigned ones and zeros in a random way, right? These are arranged in an hypothetical manner. Now, uh, if I want to see the last 10 values, what should I write from the data frame? If I want to see the last 10 values from the data set, what should I write?
So can I say, sir?
Yes.
Sir, df dot tail
df dot
tail.
tail. What this dot function doing? Dot operator.
So
What
it will
this?
show the last 10 or last 5 datas of the data frame.
So df is basically, df is an object, that is the object of a data frame, which is named as df, right? That is the object name. So df is basically an object. Dot means dot is an operator which is accessing the function. What function is accessing? The tail. Tail is basically a function. So df dot tail, with the help of this dot operator, the last 5 values will be displayed. So with the head function, we are seeing that by default it will takes the first 5 values, and if I want to see by default the last 10 values of the data frame, then I will use the df dot tail. Now if I want to specify the first 10 values from the data set, then I will, what should I write? df dot head, the first 10 values. I will mention the 10 over here. The first 10 values will be displayed. Now, if I want to see how many columns over here, what should I write? df dot columns, right? All of the columns of the data frame will be displayed. Now, if I want to visualize the data set, then I have to write plt dot scatter. Suppose I want to visualize the 2 columns, the data set with respect to the 2 columns. Suppose the blood pressure, Yes. Skin thickness. So this is the data visualization. That is the data visualization of the given data set, right? So this is the data visualization with respect to the two variable, with respect to the two attributes. One is the blood pressure and insulin. Now, which one is blood pressure and which one is insulin is not demarcated in this diagram, because I am not using the labeling part, right? I am just assigning the column of the blood pressure. This is the blood pressure. This is the insulin. So they are taking the data values of the blood pressure, they're with respect to insulin, and they are these scatter plots. The scatter plots are plotted in with respect to these two columns. With respect to these two columns. Now, I don't, I didn't mention any labeling over here, but uh, this is supposed to be this is supposed to be the x-axis is supposed to be the blood pressure, and this is supposed to be the y-axis is supposed to be the insulin, as far as the data set is concerned over here in the data frame. Now the task is that if I want to label this thing, what should I do? You will do it in your home. I'm just giving this one. You have to make a label over here and the label over here. This task is the home task for you. What should be the coding? How should I code? Now these things I explained, but I'm again explaining this because in order to create the model, I have to go through this code. Without that, I cannot able to create the model. Now for preparing the data, now I am preparing the data. That is the predictor variable. That is I am using x equal to data df dot ilog ilog, taking consideration of the whole data set, comma, with the zeroth column, sorry, with the zeroth column, dot values. Sorry. So these are the values of the 0th column dataset, right? So if I want to get the values of the particular column of the dataset from the dataset, I have to mention the iloc function. And in the iloc function, I am writing this double colon, means it is considering the whole data set of the 0th column. It is considering so these are the data values of the 0th column of the data set. Similarly, you can calculate that considering the whole data set of the first column. Similarly, taking consideration of the whole data set of the second column, you are getting the corresponding values of the first column and corresponding values of the second column, and so on. So now here also the data set is assigned with an array, because I am using this third bracket. That means the third bracket signifies that the data set should be arranged in the form of the array, as I am using the numpy library function. So the data set will be visualized in the form of the array. So this is the values for the predictor variable. Now, if I want to take the values of the target variable, so df y is equal to df dot ilog, taking consideration of the whole data set of the first column dot values. So these are the values of the target variable. That is, these are the values for the yth column. And the values are arranged in the form of a numpy array. So in the article, the coding is different, but I am coding in a different way, right? So whichever, I will give the article link to you, and I am coding in a different manner. Whichever is feasible, you can apply. Now, from sklearn dot model selection, import model selection, import train underscore test underscore split. Then I'm writing X, sorry, the X is defined X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test, which is equal to train underscore test underscore split X, comma, Y. Comma, test, sorry, test underscore size. Suppose 0.2, comma, random state, random underscore state equal to 0. So if I say X underscore train and Y underscore train, X, sorry, X underscore test. So this is basically I am splitting the data set into two parts. One is for training, another is for testing. So training is for used for developing, is for eval, is for building the model. I am building the model with the X train and Y train using this number randomly, and then I am testing the model with the Y test, right? With the actual value. So these are basically used for training the data set. With respect to this data set, the corresponding uh, the predicted values for those training data set is are as follows, right? For the given data frame. Now, how far these data values are accurate with the actual data value, that is the white test. So these are basically the random values which can be used for building the model, and with respect for the predictor variable, and with respect to the target variable, these are all random variables. Similarly, the X test is basically used for randomly. They are also used randomly to measure the accuracy of the model which I want to develop. So these are basically for X test is basically the predicted values which may be mapped with the actual values. Now, if I want to see the dimension of the training set,
So how we understand that the test is how much accuracy?
at that I'm going. These are
Okay.
these are the predicted values. Now I will put these predicted value into a linear regression model. Now how much it is accurate with the target value, that will we will calculate. X underscore train dot shape. So there are 614 rows for which are used for training the model, that is for building the model. So with the help of the 614 rows, I can able to get the corresponding the predicted values, and I can use those predicted values into the model, and by which that is to by which we can able to implement the algorithm. Now, from sklearn dot linear model, import So importing the linear regression. Import linear regression. Then I'm using a model equal to linear regression. So model is basically the linear regression model. So linear regression. So let's see. So the next is the building the linear regression.
So your screen is not visible, sir.
Yes. Mm, This is visible now. Is it visible? Is it visible now?
Yes, sir.
So from sklearn dot linear model, sklearn is a library. The model which we want to design now with the given data set is a linear model, because the regression is basically the modeling of regression. As I told you, it deals with continuous function. Regression analysis is always a continuous function, and it shows the estimation of the different vary between the different two variables. It may be the two variable, it may be a multiple variables. So, and the model is basically a linear, not any non-linear. And for the linear model, we use the linear regression, and therefore I'm importing the linear regression. From where? From the library functions of the Python. And the name of this linear regression model, I named it as a regressor, right? So from sklearn, and I want to fit these data set into this regression model, into this linear regression model. Right? So for fitting the data set into this linear regression model, what should I do? I will say model dot fit what I am fitting, the random values of x and y, that is X train and the Y train. X train, comma, Y train. Fine. Just a minute. So, mm, if I want to bring a intercept. Now the thing in the model. If I use this intercept, the corresponding intercept values will be shown. Now I have to fit the model X and trend values into the model. Now, sorry. So this is fitting the regressor into the fitting these values into the model. Now after that, I have to use the intercept, right? So I will write regressor regressor dot intercept intercept underscore model object. In Google Colab, there are two problems. Have you understood up to this part?
Yes, sir.
But this is a problem arises. So hmm, yes, underscore string string dot issue minus one comma one. I use X capital X underscore string dot dot shape similarly C Y
So your sound is very low.
Y underscore train dot reshape minus one sorry one comma minus one. So So after reshaping the y, we are getting this. Now, if I say that x capital X underscore trend underscore trend is equal to capital X underscore trend dot reshape minus 1 comma 1. Now if I say X underscore trend dot dot shape now we're going to fitting y underscore trend dot dot shape so now yes, so the linear regression model is set. So why the error is taking place? Because the I am the because I am not able scaling those datas. So before, if I want to establish a linear regression model, so the I have to scale the data. So both x and y, scaling of data means both x and y should be of the same dimension. So if there are in different dimension, if the value of x, if the value of x dimension and the value of y dimension does not mismatch, then it will show the error. That is, the model will not be established. Right. Now, if I want to make the model, that is the regressor, regressor dot intercept, right? So it will intercept at 116.327. That is the interception, that is the line of interception of x and y will be at the point of 116.327. That is, x and y will be cut each other at 116.32. That is 116.33 approximately. If I want to make the, that is, if I want to see the coefficient of the model, that is, then we can say that regressor dot coefficient, right? So the coefficient of the regression will be is 1.18, right? The coefficient of the regressor, that is the coefficient of the regression, coefficient of regression, that is what is the equation I'm writing? Y is equal to beta 0 plus beta 1x plus beta 2x. That is the that is y0 is equal to beta 1 beta 0 plus beta 1x plus epsilon. That is the coefficient of beta 0 and beta 1. The value of those betas are 1.17, right? That is the value of those, the coefficient of the predictor variable. That is the linear regression, the linear regression equation, right? The linear regression equation, that is the linear regression equation. Y is equal to beta 0 plus beta 1x, beta 1x plus epsilon, right? So this beta 0 and beta 1, the value of this beta 0 and beta 1 is over here is 1.17, right? So the model is established. Now I have to evaluate the model. Now again, when I have to evaluate the model is established, after that I will have to evaluate the model. Now for evaluating the model, we have to use the test set, that is the X test. Then what should I write? Regressor, regressor dot predict, predict. After that, I am writing X underscore test, right? Sorry, I have taken scale the model, that is why the error is coming over here. Then I have to again the scale the testing the scale the data is over here, otherwise the error will come. So I have to again scale this X test, and then I have to shape, and then I have to predict the model, otherwise the error will come. So just a minute, just hold on. Anish, are you there? Anish, Anish, are you there? So can I give you a break for the 15 minutes and then we will back again? Can I give you a break for 15 minutes, 15 to 20 minutes, and can we back again?
Okay, sir.
Okay, sir.
So there is a break for 15 to 20 minutes and again we will back.
Yes, sir.
Yes, sir.
Now, everybody is over there. Is it visible? The screen is visible to you?
Yes, sir.
So what we done over here from the code 44, the code number 44 shows that so if I want to scale, if I want to establish the model, I have to first scale the data set. So without scaling the data set, I cannot able to build up the model because the data are arranged in a random fashion. So I have to scale those data, otherwise I cannot able to build up the model. So in order, so here I first, that means I have to make the dimension of both x and y in a similar way. So I reshape the model, and after scaling both x and y, I sorry just so after scaling the x and y, I entered the values of x and y into the model, that is the regressor dot fit. The regressor dot fit means that I have to first enter the value of both x and y, and the model of linear regression is established as it is shown in the output. Now, regressor, the code number 45 shows the intersection between x and y with the, that is where the x and y axis are intercept with each other. That is this one. That is the interception of the line takes place, the intercepting point. So, so the interception of x and y is taken place at the, with respect to y axis is 116.32. So the coefficient, that is the beta 0 and beta 1x, the values of those coefficient is 1.17. Now, this X test is for testing the model. That is, I have to predict the model, and the test X test is used for the predicting the model. So in order to predict the model, again, I have to, these things are for building the model. I have to reshape, that is the training set. I have to reshape the training set of both X and Y. And for testing the model, I have to again reshape the test set, that is the predicted value of the test set, and I am reshaping the model. So I'm reshaping, that is I'm scaling the dimension of the x test, and I'm passing those x tests, that is the predicted value, into the model. And these are, and I'm getting all the predicted values of the x test, all the predicted values. These are all the predicted values of x test. Now, this predicted value is stored in a ypred, another variable named ypred. That is all the predicted values are getting. And these are my all predicted values, and these are the actual values. The actual value. These are the predicted value of the predicted values, that is the predicted variable, and these are the actual value. These are probability value, these are the actual value. Now I will calculate the how much this predicted value is accurate with this y test. So how much, in order to maintain the, in order to test the accuracy, I have to see that how much error is present with this predicted value and the actual value. So there are various error calculations are over here for evaluating the model. Number one is the mean absolute error, the mean squared error. There are different errors by which we can able to evaluate the model, right? So these error calculation we will see on the next class, right? So up to this you proceed. In the next class we will see the error calculation. error calculation, that is the evaluation of the model. The last part of the regression analysis, that is the evaluation of the model, right? Now, have you understood these things all up to the code 50 and 51 and 52? Now this coding which I have established, you cannot able to match this code from the material I will give you. They have done the different way, I have done in a different way, right? Whichever is feasible, you can do it, but
Sir,
right, okay, yes.
sir, can you share this file with us, sir? The code that you are saying.
This is a now this video I will share it.
Yes.
Okay, I will share it to you.
Thank you, sir.
Have you understood these things? Have you understood? Okay, so I will stop today over here, right? Okay, fine.
Sir, next class কবে হবে স্যার? Next class.
Next class will be mm, I think Sumit sir will inform you, but next class probably on the Monday. If it is possible, I will take on Saturday, and if it is not, then it will be on Monday.
All right.
Okay. Mm. Okay, fine. Thank you.
Thank you, sir. Good night, sir.
Good night.